if you remember last week, we built this model that I've got here, which is the model of a quadratic equation where we've got ax squared plus bx plus c. I had a starting value in this case of -10, but that's a variable, and the x step is 1 in this case, but again that's a variable, and all of that feeds into the model that I've got here, which builds the equation dynamically. As you can see in the bar at the top here, this bar is showing you what is actually in each one of these lines as you go down. Okay, so that's a model of all quadratic equations, and what I'd like to do is I'd like to use this model to solve, to find the roots of a quadratic equation. So what I'm going to remind you of is to say that x is equal to, let's put a bracket, minus b, I'll put plus or minus, I'll do it my way, which doesn't work in Excel, so that's b plus or minus sqrt, which is the square root of b squared minus 4ac, bracket divided by 2a. Okay, that's how you would, and actually if we're putting this into Excel, I would need to put in a bracket there and a bracket there. If I didn't put those brackets in, it would divide the numerator by 2 and then multiply the whole thing by a, which of course is not what you want. So that's the equation for the roots of a quadratic. So what I'd like to do before we calculate the roots of a quadratic, I'd just like to look at the square root term here. We've got b squared minus 4ac. Now you could argue that there are two separate cases here, but I'm actually going to argue three cases. So I'm going to say that b squared minus 4ac equals, I'm going to set that equal to that, and I'm going to say that that is equal to, this is b, so it's b times b minus 4 times a times c. Okay, so that's b squared minus 4ac, and in this instance it's actually equal to 16. So what I'm now going to do is I'm going to have three cases. So I'm going to say, let me just say greater than 0, equal to 0, and less than 0. Okay, so I'm having those three separate cases for b squared minus 4ac. So if the value of b squared minus 4ac is greater than 0, then the square root is going to give me a real number, okay, which means that x1 and x2 are going to be both real numbers. So you're going to have two real roots. So I'll have x1 there and I'll have x2 there. So when b squared minus 4ac is greater than 0, what I'm going to say is that that is equal to, I'm going to put a bracket and say minus b, which is there, plus the square root, no, I'll do the minus first, so minus sqrt brackets, and then it's going to be b times b minus 4 times a times c. Okay, so that's b squared minus 4ac. So that's minus b minus the square root of b squared minus 4ac. Then I need to close that bracket and then divide by, open bracket, 2 times the a value, which is actually 1, but I'll stick it in anyway, so when we change it, it will work. Okay, put that in, and I've got the root of minus 3, which, if we look here, that looks about right, doesn't it? Now, to do the next one, I'm going to be lazy. So what I'm going to do is I'm going to copy that formula, because it was quite hard to enter, and I'm going to go into this cell here, and I'm going to paste the formula in. So I'll just do Control V. I'm going to press enter, and it gives me minus 3. So that's the reason I did that, is just to confirm that I've copied it across correctly. And now what I want to do is to edit that, because this one is going to be plus the square root, isn't it? Actually, I'm going to do it the other way around. Like I said at the beginning, I'm going to have plus there. Okay, so there we go. So I've now got one of the values is 1, so that's sort of here, and the other of the values is -3. But let's just quickly look at the table. One of the values is 1. Where's my mouse gone? There's when x equals 1, y is equal to 0, and then when x equals -3, y is equal to 0. So I've got the two roots there in the table, but I've now calculated them in this curve here. Now, next thing I want to do is, if the square root is equal to 0, I'm just going to copy, no, I don't even need to copy that. So if the square root is equal to 0, I'm going to get two coincident roots. And what that means is, just imagine lifting the curve slowly. As the curve is going up and the x and y axes stay still, you can see that the two roots are getting closer and closer together. And at the point when the curve just touches the x-axis, the two roots have actually moved so they are the same point. So that's called coincident. You've got two coincident roots. Okay, so in that case the square root is 0, so the value of this is equal to, I still need a bracket because it's going to be minus the b value, which is there, okay, and that's going to be divided by 2 times the a coefficient. All right, and then I need to copy that, Control C, because that's going to go into there, Control V, and that's going to be the same value. But in this case that's not actually true, because this isn't equal to 0, and I'll go into that in a second. In fact, I will go into that now. So what I'm saying here is that if the value is greater than 0, these are the roots. But if the value wasn't greater than 0, I mean, imagine this was, that's -3. Let's try -2. Let's try 1. Yeah, okay, that's fine when it's equal to 1. So when it's equal to 1, you see the roots here. The x values are -1, and they're both the same. And if this then became 2, then I've got a problem. You see what's happened here? It said you're trying to take the square root of a negative number, and it's not allowing me to do that. So what I'm now going to do, let me zoom into here. So rather than have num popping up on my equation here, I'm going to use a conditional statement. So if I press F2, what I'm going to say is if bracket this cell is greater than 0, comma, then we have the thing that we calculated before, otherwise, that's what the comma means, we'll have nothing. So I'll put 2 quotes to say I don't want anything in there, and then when I press enter, you see that's vanished. Now let's do the same for this value here. So I'll do it again. So it's F2, so I'm going to say if brackets b squared minus 4ac is greater than 0, comma, then we calculate the bracket, otherwise leave it blank, close the bracket and enter. Okay, so at the moment, let me just zoom out a little bit. Zoom out a little bit. Okay, at the moment with that value for C, there are no real roots. But if I make that to be -3, I think it was before, now you see the two roots have appeared. Here they are, because the b squared minus 4ac is a real number. Now I can do the same for this value here, which is to say F2. So if b squared minus 4ac equals 0, then show me this value, otherwise show me nothing. Bracket, and I'll do the same on this one, which is F2. If b squared minus 4ac equals 0, then show me the value, otherwise don't show me anything. Okay, so we've got x equals -3, we've got two real roots, which are these two roots here, and then if we lift that up, what was it? Where was it equal to 1? Yeah, there we go. See what's happened there? B squared minus 4ac is equal to 0. So the real roots are now not being shown because we've got two coincident roots. You could argue that we could just amalgamate those into the same cells, but I'm just trying to point out that you always have two roots for a quadratic, and in this case they are two identical roots, and when this is equal to, I don't know, -1, then you get two real roots, which is 0.4 and -2.4. Right, so there is another step that I want to take, but I think today is not the time to do it. So I'm going to leave the model there for the moment. I'll encourage you to have a go at it yourself and see if you can do that, because that's quite complicated that we've just put into there. And then next week I'm going to move into the imaginary roots, so we'll have a look at those as well.